All right, we are live. Today, hopefully, we're actually going to be streaming what I initially titled the thing. Because last time I was going to try to get strings working, but all I ended up getting working was. Where are you? It was. There you are. We got like malc and free working by externally kind of linking those in. And then off stream, since then, I have gotten strings working again. So basically, behind the scenes, the way that this is working is we have this string BS file that our scripts import in. This is just a string with two data types of the, well, these are the data types we use behind the scenes, but ref char, you wouldn't really be able to use that directly to access the data because it would just, the scripting language would treat it as a reference to a singular char, not a list. But I mean, it is a pointer to a character behind the scenes. So I need to come up with a way to have private variables, but it's not very important because the language kind of like everything's through structures. We'll just say, hey, if it has an underscore, maybe just don't use it. But yeah, then we define all the constructors as external, and then all of the other functions that we support here. And then all of these functions are defined by the BS string class. So it's basically just, your basic string class with too many memory allocations, so it's kind of inefficient, but what are you gonna do? But this is actually where we define the native library. So you can see we define every single function we're using here and pass it in, plus a hidden one we don't put in the header file because we only want the compiler to use this. But we just go string from char array, this pointer, well actually return pointer. It doesn't really matter since it's not actually exposed, but this converts the constant strings into our class. So every time we have a constant string we're loading, it calls this. So yeah, that's what I did off stream. This stream we're going to be looking into function pointers, and then if I'm still going after that, we will be looking into lambdas with capturing variables. So hopefully we get to that point. We shall see though. Yeah, let's get started. To show you what I've done so far before I decided, even though it's nearly 12 a.m. in the morning, afternoon, 12 a.m. We'll start streaming. And I did just wake up after a very good nap, so I'm probably going to be streaming till the sun comes up. But yeah, we just added this function reference context labeled to our document context set of document context nodes, with the idea that it will work like a labeled reference context, but for referencing functions instead of labeled variables. But yeah, we just defined this new type. We added function ref to the value types. Alright, back to what I was doing. Let's just go straight to create AST after this. Just define other functions, return new. And now let's figure out, oh wait, wrong class. It's like, why is it already defined? I haven't defined that yet. Now to figure out how to actually define a pointer to a type of function pointer. So it would probably be a constant. So yeah, this is probably going to be LLVM. It would be a constant int, I believe. But we could also do a pointer to a null type. Oh, there's a function pointer type. That makes sense. Oh, this is floating point. Okay, not function pointer, floating type. Just wanted to make sure. So it is gonna probably be a constant int. Oh, that's interesting. You can do constant expressions through the actual AST. I wonder if there's a way to grab the value of that so that I can get rid of this whole thing and not have an interpreter, like an entire tree walking interpreter. That'd be really nice. I may actually look that up. Okay, we'll bring this over here so there's not just nothing on stream while I'm going down rabbit holes or whatever. LLVM. A constant value that is initialized with an expression using other constant values. Okay. We won't worry about that too much right now. Don't want to get distracted. Constant int. Oh, does that have to be an integer type? Okay, we'll do constant void then. Constant pointer null, since it is technically a pointer. All right. So it looks like we might need to bit cast it either way. So we might actually use constant expression here. It looks like one of these solutions to creating this is and expression get bit cast, and then we just cast our function to the context like that. So now we just need to actually grab a reference to the LLVM function. And then hopefully we've already defined this. So I need to throw that. We need to make sure that when we reference functions as function pointers, we add them to the function call tree, so they're actually sorted correctly. And this should be our function pointer right here. Well, let's go into the static analyzer and decide on a way to actually define these. don't think we're actually using this anywhere. I mean, it's there, but we don't really use it anywhere. We automatic cast stuff a lot. So I might be able to just delete that and we no longer have like the ref prefix. Now again, that might be a good way to make references to a function, but then again, we still need to be able to get a reference to a function. So we might need to rewrite how this all works. Because right now, function calls and member function calls are written directly into the grammar, where, I mean, this can, member function call can recursively use member access, so we like member access a couple times and then do a member function call. But actually, I know how we can solve this. We just make everything a function pointer, and then when we run the optimization pass, it should just call stuff natively. And then we make sure ID Now it's hard because how do you store every single override that it could possibly be? Because we can have multiple overrides. And one thing I'm wondering is, how do we handle if a function has two overrides? There we go. Let's say theoretically we had two functions. Int func int a and float func like this. How do we specify the correct override that we want to grab a pointer from? Obviously in C++ we just have funcref, and then I think we just say like get the reference of a function. I'm trying to remember how we do this. So obviously if we define the specific type for the function like this, it's going to just automatically cast it to the correct type like that. And then we can call funcref like that. And then if we want the float override, we just get the flow override. Now, how do we actually translate this into our scripting language? I think what we want to do here is just we need to use I would prefer to use the same system for everything. So instead of having function call, member function call, and then a separate grammar for setting references to functions, instead we would just jump straight to figuring out a way to pass overrides of functions. Here's what we're going to do. We're going to create a function override. Is that how you spell it? Override. Probably without the ES. There we go. That's the correct way to spell it, I think. Function overrides context, and in here we're just going to have a list of function context pointers. Into here, we're just going to pass the list of all possible overrides for this function. And then wherever this function overrides context gets passed to, then that context will try to find the best override for its specific use case. So if, for instance, we are doing a function call, we'll no longer have to deal with member function call because, well, we'll cross that bridge when we get to it. But basically, we'll delete this eventually. Member access will just return an overrides context. Then function call will take an expression on the left side, and then according to the arguments passed in, we'll search through the overrides context. No more member function call. So let's just start making these changes now. We'll take an expression here. And then in member access will return an overrides context if it is a function. And then over here in ref assignment, we can just check, like, if this is a function reference and this is an overrides context, just find the best override. Otherwise, you know, if this is a function reference and this is a function reference, just copy it over. Let's generate this real fast. There we go. So you know it worked when you got the error pop-up. And now member function called context is going to be throwing an error. And now we have to change this. So it's no longer going to be resolve function call. Instead, we're going to split it up into two functions. One that grabs overrides, and then eventually this one here that finds the best match. So this calculate cast cost. Let's copy this into value context. That way we can use it outside of the static analyzer since it already was a static function. So type value. So in here, instead of current, we'll just use this pointer. And there we go. Now back in the static analyzer, let's just left return type, now calculate cost. Right, return type, calculate cost. I need to figure out a way to turn that off because I hate that formatting. What was I gonna, oh, right. All right, back to work. Let's see. Ah, here it is. I like that a lot better. For resolve cast, oh, not resolve cast. I think we're going to refactor this to be get overrides instead. So we return a function overrides context. And we pass in a name and yeah, the scope. And why not? We'll pass in those as well. And we don't need to pass in an error since technically this shouldn't ever return errors. It will just return no overrides, because this best match function is after we find all the overrides. Then we just create new function overrides context and oh, it's a list. That's why. And this is where we return all of the overrides. We'll still return an overrides context if there are no overrides. And we'll let the the callee decide how to handle that. And then instead of resolve function call, we're going to call a member variable on the overrides context called best match, or best match. For that, we're going to take that half of the function and throw it in to here. And I'll check to see what we're actually using for arguments. Actually, no, what we were using for arguments was a function call context, which was terrible. So yeah, we'll just pass in a vector value type. Come on, IDE. I can't exactly manually define it at the moment because I would want to copy this over. Right now I have a bunch of stuff in the key. Yeah. Okay, right here, function context. I think that was the signature. Oh. That's right, we want value context instead. Because value type only stores the base type, not if it's like a reference or anything. I delete args. Oh wait, yeah. And this resolve cast is a little bit problematic. We'll just say the callee will have to handle it. For now, we're just going to comment that out. And we're going to return best match for that. Yeah, I've been trying to do my best to make sure that the error messages are actually useful. And most of the time they are. The one thing that I haven't figured out is how to make the grammar and lexer pass good functions. And I guess I technically should put a little bit more effort into that. But for stuff to do with types and whatnot, I think it's pretty decent. But yeah, in the static analyzer, technically up here, I do override like the lexer and parser error listeners, but the errors that I record are not great from there. So that might be a topic for another stream, is errors that don't print out kind of a bunch of gibberish. And we're going to be copying these error messages back to the places that are going to be calling this function. I think I'm going to set up a set of flags for searching through the functions. Half because I felt like it, half because there wasn't really a scripting language that really matched what I wanted. So I just decided to make my own. Hello, how's it going? And I am building this with LLVM on the back end, so with the hope that hopefully if I'm not able to keep up with the needs of the game engine on the back end, because I'm building this for a game engine, if I'm not able to keep up with what I need for that, I'd be able to look into maybe throwing a different LLVM supported language into here instead, like maybe Rust. One day my engine might have Rust support. That would actually be pretty cool. Oh, nice. Yeah, I actually started out on this until very recently without using LLVM. I was using this library called asimjit to uh, generate the machine code on the back end because what I'm trying to build is an embeddable programming language. So, scripting language that loads scripts at runtime for another function, not a function, program to call. So, like a game engine would load the scripts and then call it after that. So, unfortunately, I wouldn't be able to just directly output machine code and spend time doing that. One day, maybe I'll make an entire compiler from scratch, but not right now. How difficult do I think C++ is? Is on the more difficult side. I'm not the best judge at the moment because I've spent enough time in it that I'm very comfortable in it. So it's easier for me than other languages just because the very strict type system makes it very easy to figure out libraries without looking at documentation because they almost document themselves. You can just go to like the definition of a function and you see exactly what you put into it. So I think it's easier in that regard, whereas something like a lot of web-based languages, you kind of have to guess at how to do a lot of those things. So it's up to personal choice. Oh, nice. So it's a interpreted language? Let's see, what do I have in there? Okay, cast count, which is that. And where is this getting referenced from? No usages of compare function args. Okay, so I can just throw this directly into the function. Oh, nice. That's similar to the very early versions of this language. Well, my first attempts at it. I always knew I wanted to JIT compile stuff before the JIT compiled version of this language. I had a different language that I worked on, where yeah, I did just do a bunch of enumerators, giant switch statement, and just interpret it that way. But yeah, it's a really, really fun way to build them. Oh. Okay, yeah, stuff like this. I really do need to hook this into the rest of the static analyzer somehow. Okay, so you're just doing go-to statements and whatnot. That's pretty cool. You know what? I'm gonna do this the correct way for once. Have this be a function that returns a Boolean with one argument that is a unique pointer to an expression. And it is a reference, so they can modify it. So when a cast is required, so the syntax of the scripting language, let's see, what's a good example? It's very similar to C-style languages, closer to C with a bit of C# thrown in, because most of the time, well, we only support structures at the moment. So no public, private variables, that sort of stuff. And the only way to pass those structs around is through references. So you can have reference variables, so obviously pointers on the back end. But yeah, I don't want to expose the ability to use raw pointers directly. The idea behind the language is it will work a little bit like functional programming, maybe. I'm not sure. I haven't used functional programming, so I'm just like, it might be like how they would work. Where you have the host program and it calls the scripting language, and then the scripting language doesn't actually allocate any memory on the heap ever. That's kind of the general idea. It would just allocate everything on the stack until it returns back. And the way that you would return stuff to the host program is the way that I do the calling convention of my program is whenever you return a struct, secretly behind the scenes, it's actually a reference to an already allocated struct passed in. And it can actually, you can set an unsafe flag and then do like raw, malloc, and freeze. But again, you have to set the unsafe flag, so most scripts shouldn't be able to actually access the unsafe library. So that's the general idea. And I feel like that's going to work really well because the engine that I'm making is entity component system based. So most of the data should be stored in the entity component system and not in pointers. Polish negotiation language. I am unfamiliar with that term. Oh, so it's more for like mathematical programming languages. Okay. Nice. So the thing about the cast callback is we have actually, let's do this the right way. Oh, joy. Okay, that's better. Yeah, the thing about having a cast callback is, yes, now I can do this and automatically do casting, but what I really need is okay, instead of this, we're not going to have it where this can auto cast stuff. We'll still give that responsibility to the caller. Instead, what we're going to do is should cast, or call this implicit cast. Called it to check if an implicit cast is possible. And in here we're going to pass a value context from and a value context to. actually, instead of args match, we could just directly continue. Ooh, case insensitivity. That is a bold move. There we go. Actually, right, I can't do just a straight continue because this is within a for loop, so it's just gonna stop that for loop instead of what we want. Oh, I want this just to be regular cast count. Right now, it is GLSL compiled into SPIRV, which I then load with Vulkan. So this is ahead of time. Okay, 1 second while I put the one-liner definition together. Ahead of time optimized JIT compiled language. So the idea for the game engine is that it loads in all the assets at runtime over the network, so like downloading it in similar to a web game. So the scripting language obviously has to be loadable at runtime, but I still want it to be as optimized as possible, so we generate LLVM bytecode, we optimize that bytecode, and then we store it to a file, and then later we can load that. So yeah, basically JIT once on startup. But hopefully optimized pretty well from the editor. And down here. And I think this will work, possibly. There's a chance. Now to refactor the other stuff. I can just delete this. So LLVM, it compiles down, inside of LLVM, the library, it uses a low-level intermediate representation that's very close to, it's very close to assembly language, just a little bit higher level, and then that is then, I believe what it does on the back end is it compiles that to the native assembly of whatever the target is, and then that to machine code. It might skip that step. It's just, I have a sneaking suspicion that it does that extra step of to assembly and then to machine code, because in the runtime, when I'm setting everything up, I have to run this initialize target native ASM printer and parser. So I'm suspecting it uses assembly language on the back end. Did I just rename this? And it should be super easy to do that if you already have it in ASM format, because the LLVM library is actually, it's pretty easy to use if you understand how a compiler works already. Like if you understand assembly language, LLVM is easy. What you would want to do to transport it to LLVM is you probably want to generate LLVM bytecode and just call like the LLVM write to file function. And then you could send that off to, anyone using that could send that off to whatever LLVM supporting functions they want to. But yeah, it's, yeah, creating the LLVM AST is super easy. Okay, so this function is already the way I want it. Resolve function call, we're just gonna delete this. Yeah. I was using ASMJIT before, but what I wanted to do with the language was quickly getting out of scope of my optimization. Like, I very much wanted to have really good ahead of time optimization, but like, it would have taken me a long time to make a good optimizing compiler from scratch, so I decided to just bite the bullet and switch to LLVM instead. So there's definitely going to be more latency actually loading scripts on the fly, but hopefully it will be worth it in the end for how fast the scripts will run once they're actually loaded. Right, you would still be able to generate LLVM stuff from that, because the way they label functions is super forgiving. They have a name mangler that automatically takes care of like all the special functions and whatnot, so you could literally refer to functions by numbers in the IR. Okay, let's... Now to actually use all this stuff we've been refactoring, which is going to be a pain, let's just go down the list of problems. Visit member function call. We can just straight up delete this. Oh, I still have a version of resolve function call out here. Okay, that's why I was like, where are the errors? There should be a lot more errors. But no, we just delete this and watch the errors appear. Ah, look at all those. Actually, not too many, but... So first one is in resolve cast. So yeah, let's just take care of this real fast. So first we're going to grab the overrides. Let's see. If you're interested, I do in fact have an LSP server implementation for my language. If you kind of want to look at how I implemented that. I wasn't able to find a... well, I found a couple C++ libraries for the actual LSP protocol, but I didn't really trust them too much, so I built my own LSP implementation, and it just uses ASIO for the networking on the back end. I kind of copied the networking that I was using in my server, but yeah. If you want the GitHub, have I linked it in my description yet? I'm not sure if I've linked it there yet. No, we want Brane Script, not Brane Engine. So yeah, let me drop this in chat for you. But yeah, it's super simple. At the moment, it's mostly highlighting and type checking. I don't have anything for like suggesting functions and auto-completion yet, though the way I'm doing document context hopefully will make it easy to do that in the future. But right now it was mostly, I wanted to get the static type checking in there, and then the highlighting. Those were my main focuses. Yeah, let's fix this real fast. Yeah, for as language as low level as yours seems to be, you wouldn't really need, all you would really need is the compiler output. Let's see, no scope and no template args. Autocast is also false. Actually, since, is autocast being referenced? Okay, cool, we can just delete that. Yeah, because this is just finding every override of the function with a name. Or the same signature, I guess. Even with different arguments and whatnot. And now we can go back to here. We don't need this argument. Okay, I actually like... I've been trying out the free trial of GitHub Copilot, and occasionally it comes up with really good stuff. It's very good at mostly converting one type to another type. So if it has reference text of how to do something, or it's like a statically typed language, it's been really good at automatically doing conversion functions and refactors and that sort of stuff. Overrides. No casting operator found from return type to signature. The human readable output looks a lot like assembly, but all of the commands are assembly level commands. Yeah. So it is typed, but just like assembly language, there is an unsigned and signed. So it's typed on the level that registers would be. Maybe a little bit higher level of typing than that, because like pointers are typed and whatnot. But yeah. Trying to decide what to do with this error message, because there are two instances where it can do this. Because cast overrides, this is going to find, wait, technically there should only ever be one override from, okay, this will find every override of any type to the type that we are casting to. Okay. And then we want to cast overrides. No, we don't want to just do overrides index 0. That'd be a terrible idea. We're going to say cast overrides best match. And then our arguments are going to be, okay, that's already a value context. So we can just braces that. And we're not going to be implicit casting this, so we're just going to return false. Oh wait, did I put flags first before that? Oh. Okay, no, I did put the cast callback first. Last argument is const expression, which, let's see, is this within? Okay, it is. So if we are enforcing const expressions at this point in time, if only it actually found the enum const expression. Otherwise, we'll just pass in. Can I get away with 0? Nope, I can't. Sure, I can take a look at it. Let's see, do I just... Do I want to just copy this twice? Actually, best match should... It still runs because we always return a... We never return null pointer from this function. Wait a second. Okay. So best match is if overrides empty, return null pointer. There we go. So now we keep that same amount of efficiency and only one error message, copy of the error message. I'm actually going to use this one instead of this one though, just because I like the message more. Let's take a look at this. So this is what the language looks like on the back end. Okay. So very close to assembly, but just a little bit more cross-platform than raw assembly. And then these are, well, labels, I guess is what you would call them in assembly. And then I'm guessing you have something like a go-to statement where you can jump to one of those as well. It's pretty cool. Oh, jump below, jump above, all those sort of conditional jump operators. Okay. That's right. That's how that works. I've only been using LLVM for like a week and a half, and already I'm forgetting my assembly language knowledge. I'm gonna leave this one for later. And that one. I should probably just create helper functions for whenever I want to call a constructor or destructor. Or maybe I'll just make a resolve function call function again, but make it a little bit cleaner than the last one. But yeah, let's do visit function call first, because this is the main use case. So instead of resolve function call, instead we're going to do the same thing with oh, jump and go back. Okay, that makes more sense. and then go back as return. Okay. So not exactly like assembly language, but very close. Okay, what did I name the function? I keep forgetting things. What? Negation operators don't work? Let's see, what's the name for it? Unary arg negation or something like that. I technically don't need this anymore because I have function signature generation functions. So I might come back and delete these later. They are from a less civilized age when I didn't have the function context. I didn't have document context signature stuff yet. I know a little bit about audio in C++. It's a little bit annoying because there isn't one really good API for every OS, but to kind of teach myself how audio APIs work, I actually made an entire chiptune editor. So yeah, I have this project called Simple Synth where I basically used native audio API and made a chiptune editor. Do I have a version of it here, or is it only on my laptop? Project from version control. Let's see if I can just build it real fast and show it off. Got me down the rabbit hole. Let's see. Okay. Do I not have Pulse Audio installed? So Pulse is what I used on Linux. Okay. Because my laptop already had that installed on its dual boot. I do have audio running on a separate thread, but the APIs that I'm using are actually asynchronous. So technically it doesn't need to be on a separate thread. Yep. So yeah, on Windows I use the native Windows API, and then on Linux I use Pulse Audio. I feel like I would have already had installed. Anyway, I have to take my word for it. Pretty fun. Pretty fun project there. Actually, it's probably that I don't have the dev libraries installed, Let's see, pulse audio. Okay, don't I want? Yeah, lib pulse dev. That's the one I want. Because the problem is we just don't have the header files. It's probably already installed. If you wanted game events on one thread to enable a sound effect on the audio thread, wouldn't be able to do that. Synchronous or asynchronous, either one. You just have to have an event system of sorts, and then basically you just need your audio system to have a way to run without being constantly updated. So you'd have an event that then started something running on the audio thread. Here in my library, I have a sound device. I can't remember exactly how I did it, but I can add different sound sources, and they have like a start time, and they take like, you know, the current time, and they play based on that. So you just, like, in my system, add a sound source with the start time of when the event happened, and then when the sound source, like the event is done, you just delete the sound source. Undefined reference for vtable for sine synth? Huh? Undefined reference to vtable. I've never had that before. Okay, recount allocation against function. That's super weird. So yeah. To communicate between threads in C++, starting out, a good idea would probably just to look into something called message passing, which is where you have a something like a buffer, usually like a linked list, and then you control that linked list with a mutex to make sure you don't have race conditions, and then you put stuff into the list from one thread and you take stuff out of the list from the other thread. So it's like a little pipeline of messages, and that's usually that's one of the more secure ways that's easy to start out with. And then you get into more complex stuff with mutexes, and you get into mutex locks, and it's a lot of fun. So my scripting language, I don't have pragma onces. It doesn't even have include statements. The way it works is you just, at the top of, so it kind of works in like modules of sort. So to link a module, you say link and then the name of the module, and then to add stuff to a module, because it's not that one script defines one module, it's that scripts can add functions to modules. So for example, this script exports this structure and then these functions to the tests module of sorts. And then, yeah, my linker just, my compiler takes care of all of the linking and collision stuff on the back end. So basically, each script just has a list of all the modules it needs, like all the modules it links to, and all the modules it exports, and then my runtime is from that able to figure out how to link everything. And then you do have to make sure, like the host program will have to make sure to add load scripts into the runtime in the order that they're in their like dependency order. So if like this script depends on these two scripts, it will need to load those two in first, because there's not an automatic way to do that at the moment, because they don't actually have a way to reference other scripts, just these modules. That's more something I'm going to take care of on the game engine side, because my game engine has a whole dependency system where it will load in the most needed dependencies first and then kind of go back to the original thing we wanted to load. So if we need to load this, we load its dependencies first, and then we load those dependencies and those dependencies, and then actually load the assets once we have the dependencies. So I'm planning to handle that sort of stuff in the game engine itself, and then the scripting language just has a really simple linking system. But yeah, I have been sidetracked for a while. Where was I? We were in static analyzer refactoring stuff. That's right. Yeah, I don't really have any preprocessor support in my language yet, just because there's not really any need for it at the moment. But in the future, I probably will have something simple. We do have templates, but not preprocessors. See, well, it was get function overrides. It was actually get function overrides. Okay, it just wasn't showing up. Oh, right, we aren't doing this in get function call anymore. Instead, we're doing this in visit ID and get member variable and access member. So when we visit an ID, and right now I just have a check for if it's a labeled value context, which is usually what we want it to be. However, actually this won't find. We're gonna have to change this to not an identifier. Visit ID. Instead of visit ID, okay. This is out of date because I've done a whole refactor on how we actually find stuff. So instead of ID here, instead I want I think it's what I use for member access. Oh, it's not. But yeah, in find identifier here. Yeah, get identifier context. Scoped. Yeah, scoped ID context is what I want here. So this is old, out-of-date stuff. So we actually want a scoped ID here. That way we aren't just using the node tree-based find identifier that will only find stuff within the local script. Instead, we want scoped ID, which we can then pass into get identifier context in the static analyzer, which will actually search the entire everything for it. All of the currently loaded scripts. So in visit ID, instead of this, we're gonna just do scoped ID. We want get identifier context. Just like that. And that's going to be a lot more reliable. And we want to do that just to make sure. And if not node and instantiating template, we do want to check to see if we have a template argument by this name. We want to do get text for the entire context. And then here, instead of checking for if this is a value, instead we are going to say auto value context node as labeled value context, since that's a dynamic cast behind the scenes. So if we are referencing a value at this identifier, we will return a value. All right, now node as function context. This is very close to what I want, but no, we do not in fact want just one function called context, because yes, it will find one override of the function, but probably not the function override we want. It's just going to find the first defined one or something like that. Instead, possible overrides is equal to get function overrides for function identifier. So just completely ignore this function context and just grab every single reference to everything with the same signature. Actually, we can just pull a return expression. Since this doesn't return null pointer, we can just do that. I am, however, going to make sure that we initialize this. Just to be sure. Yeah, if this is a function context, return all function overrides. And then in the case that we don't have that it isn't a labeled value or a function context, we're just going to record error context, then context get text not an expression. This is probably the most applicable error. I'm not quite sure what I want to put here, but this is a good placeholder for now. But yeah, now in function call context, oh, true. I do need to refactor function call context. Actually, no, I don't. We're good. But yeah, we're gonna have to change this. Yeah. I'm gonna go to the bathroom and then I'm gonna be right back. All right, we are back. Just realized I forgot to. Usually I'm better about at least zooming the IDE a little bit. I don't feel like doing 125% right now, so we'll just do 110. But yeah, instead of resolve function call, instead, we're going to say if source as expression visit expression, if this is an overrides context, oh, yep, that's not quite right, but it's close. We're just gonna take that and then delete all of it. The function call was fine. Everything else, no. Yeah, we'll have a separate version of this whole thing for function pointers in the future. If this expression is a labeled value context instead, no. If it has a return type of type reference, basically. Basically, different paths for if it's a symbol or a function pointer. Function is going to be equal to override context best match for arguments. So we need a vector of value context, archetypes, and then can explicit cast. We do actually want to define that. Oh, Copilot, you're gonna do something? There we go. Then I think we had a implicit cast viable. Which I don't remember. Oh well, it works. We'll just use that. And then the same old enforce const expression. It keeps getting so close. But nope. We want... It's going to get it eventually when it has more data. Then I want to grab the old version of this function. I like how it remembered, like, Copilot was able to remember the cleanup functions. That's really nice. Could not find override of function. Okay, we don't need to take into account scopes. So we can literally just say, I don't currently have a signature for function overrides, but honestly, that's a good idea. We'll add that. We're gonna add long ID. CKNR style. Let me do a quick Google search and I will get back to you. The one true bait. Impartial. I usually like, yeah, I usually use the almond style, but with the exception of I usually don't put spaces after statement names. Just because I like the braces being on the same line and then in line with the statement that starts that. So this makes more logical sense to me. This is fine. I usually use it when I'm coding in web languages. But yeah. For function definitions, okay. Oh, the thing where like where the type is on its own line and then the function. Very much not a fan. The C-lang format likes doing that, but I don't know. It just looks wrong to me because I'm like, what's this type doing out here all by itself? Yeah, usually I like everything on one line when possible. To a unhealthy degree, like I'll have until I had a C-lang format in here, I had lines of code that could cause heart attacks. Actually, I don't want long ID. I just want identifier. true. We could have template arguments. Actually, no, template arguments are taken care of by the actual overrides context, so I don't need to worry about template arguments. So this long ID will include the template arguments. Should we still print out possible overrides as well? I might actually want to put this filter right here on the actual where we generate the override context instead of on the best match. You can do that later though. Next, we need to handle the actual arguments. So for reference arg in, oh, okay, we already have arguments. We just need to handle the casting. And for that, we're going to copy this. If this needs to be an indexed for loop. I is less than. Say if call context arguments return type is so if this is, oh, okay, yeah, that's actually good. If this is the same base type, continue. Otherwise, we want to do a cast. So that's the same thing. How is it converting that to a parser rule context? Now we're just going to say dot range. Could not cast. To cast this to a value context, so we're not getting the name as part of the signature. Actually, no. We can cast the, we can pointer cast this. That actually would be better. A little bit more performant. Could not cast. This is the end type, so what we want is could not cast call context arguments I return type dot signature to value context, call context function arguments, get signature. So this is the function that we're calling. Make sure we don't get a memory leak right here. I know it's a little funky, but should be fine. Resolve cast from this to call context function arguments 0. And then we should have an error for the cast. Error. No casting operator found for, okay. So we could literally just, instead of having this, just throw in the cast error. And that should take care of casting. Oh. We need to take into account if not call context function and the last node, which is the call context. Actually, we can just call get last struct context, just like that. We want to create a this reference, labeled value reference, and in place that into arguments. Yes. And then we'll call best match again. So this should get implicit this pointers for if we're calling this inside of a structure. Well, this reference, if I'm being accurate to my own terminology. And I should be able to just delete all that. I do want to pop the value access document though. Now what to do if we don't have an override context. So to do call function so this is where we're going to do function pointers. Now we need ambiguous, well not ambiguous, Brane. We need to handle how to do these resolve function calls. Actually, let's do visit member access next. This is far too indented. I'm gonna refactor all this. Have a check for that. Already have a check for that. So yeah, we're just going to assert type here, since it technically should never be null. So first, and then we are going to give this a parent scope. Scope. Oh. Okay. We're gonna need to handle templates differently. Slightly differently. Very slightly differently. Actually, scoped ID takes care of template args for parents. Okay. I still need to take care of template args for the final member though. Then member access as well. So we can actually instantiate templated functions. let's generate this. Okay, this comes later. This should actually never be called. Where was I? Static analyzer. Get function overrides, and we also, if we have template, we pass in the template. So now when we visit the ID here, I'm actually going to have function be the base type for this, or base path. Default fallback. So this needs to have a case for if not node and no, not instantiating template, context template args. We'll attempt to get all the overrides with template instance with name. Do we take into, okay, that just goes straight into there. All right, so I could just pull context scoped ID, get text, and that will get me what I do want to pass into get templates. So next, the scope, which at this point is null pointer. And into here, we'll pass context template. And if func overrides dot operands dot empty not empty. Return expression, func overrides. So basically, if we are able to generate a template, even though we didn't find anything before, return that. Then over here, it's going to be the exact same deal. Okay, so I'm not even using the keyword there. Okay. Yeah, so I'm just gonna delete that grammar since it doesn't have any uses. If not empty, delete member overrides. Amazing. Perfect. I actually want to delete the access context because we're not going to be using it. And then we want to return member overrides. Actually, instead of doing that, be smarter to only allocate the member access context. After we've attempted to get function overrides. Be a little bit better use of resources. Actually, we're gonna put this check right here. there we go. So member access and visit ID both now return, most definitely return functions. Visit function call is fully implemented as well. So now I just need a way to resolve constructors and destructors of structs. I just have them linked. So for this, we could literally just go construct call function is equal to var type struct context constructor. If not, construct call function chord error. Could not find constructor for struct. That works. We shouldn't need error anymore either. All right, now I just have to do this everywhere. Destructor could not find destructor. Now we have operators. So I think we're going to do resolve cast, but instead of resolve cast, it's going to be resolve operator. value. And none of the native stuff. Oh, hello, welcome back. We are nearly done with refactoring how we handle function calls. I just have to handle calls to non-native operators, and then we are good to go. All right, that looks good. We didn't even have to change too much about it since we were already, like, the casting operator was already finding operators. So now we just go to here. Actually, we need to define one more version of this. The type with 2 arguments. Thanks for the follow. All right. Now here. And left and right. You know what, let's be smart about this and do smart pointers. Just so we're being a little bit less sketch about this whole thing. No longer want to call release on those. String cannot bind to a temporary type of unique pointer, but operator is char. So Will there be pointers to variables? I'm guessing you're asking more like, is there pass by reference? And yes, there is pass by reference. So you can define function arguments as reference, and then any modifications you do to them in the function, yeah, it is passed as a pointer behind the scenes. So the answer is yes. So I could theoretically create a type called, a function called swap and ref int a, ref int b, and I could even make it a template. We could say template, I think I say type def left, type def right. Actually, it would only be one type. We would want to do one type. And that would work. Yeah, it's basically like the, yeah, like pass by reference in C++. Because I do want to hide raw pointers from the user, just ease of use and memory safety. So, yeah. But yep, that is a feature that is currently fully supported once we get it compiling again. Oh, I already had a resolve opera. Oh, it's error. Okay, error is what's causing this. So, yes. You have to pass a flag to the analyzer to allow unsafe stuff. Well, unsafe operations. And that allows you to link the unsafe module, which has a malloc and free, malloc and free, basically. And they call C++ the C++ new operator behind the scenes, just because you aren't supposed to mix free and malloc. But yeah, so you are able to free and malloc, but only in scripts with the unsafe flag set. So for most stuff, no, you can't call malloc and free. For specific libraries and whatnot, you can set it to be true manually. So similar to how C# does it. I will admit, I was a little bit inspired by Rust. I don't have immutable by default. I was tempted though. But yeah, it's basically a trimmed down version of Rust a little bit. Yeah, that was one really nice thing for me moving over from ASMJIT to LLVM was, yeah, you don't have to worry about the weird to register dividend, whatever you call it, the top side of the division operation and multiplication. Very nice not to have to worry about that anymore. Oh, this all builds. Let's run the tests and see if the logic works. There we go. As expected, it breaks. Oh, but we get all the way to creating the AST. Wow. Wasn't expecting to get that far before an assertion hit. Okay. First up, what does the this pointer look like? Why is there a this pointer? Or not a this pointer, a move operation. Oh, because that would do it. I missed a return. Interesting. Oh, so we already got through 3 tests. That's very promising. What is going on here, though? We visit the expression. Invalid address. So which function triggered this? Was it function, signature, caller 1? Okay. So it's this one right here. For some reason, returning this function is not working out. Nice. Yeah, that sounds like it's a lot nicer to use. And I think it's the way most abstractions go, with making it so move is only registers, and then you have like load and store, or stuff like set for memory operands. LLVM does something similar. I was going to do something similar for my language. Tis the smart path. Okay, let's rerun this. Only recursion. And which function are we in? Called 1, so we want to go to caller 1, which is the next one. Yep. So this is the one causing our issues. Something's wrong with the expression. So we visit function call. Interesting. One of the overrides is null. This is valid. Okay, so we need to check to make sure that overrides doesn't have any null. So want to do visit ID. I want to check here. I'm pretty sure I would get a null pointer exception. I've generated a lot of null pointer expressions in the, not expressions, exceptions in the past. It's literally my GitHub status. But yeah, that's what I would expect to happen there. At least in debug mode. In runtime mode, you might get something a little bit spicier. Undefined behavior, very fun. Yeah, memory fault, segmentation. Size 1, called 1. Okay, so that's what it should be. Oh. That would do it. It was a GitHub Copilot thing. I was like, oh, that's cool, back inserter. That will insert it into the back of the list. But then I realized, oh, I don't want this inserted into the back of the list. I want this, like, we pre-allocate the correct size. Actually want output begin here. Copilot trying to sabotage me here. Output. There's one. So yeah, now output should contain, yep, that looks much better. I don't know how the other things passed. Type void. Oh, okay. I'm probably forgetting to set the return type of the function context. I didn't write the grammar from scratch. I'm using a, I guess, library and runtime. I'll just call it a tool. It's called Antler. So Antler 4, ANTLR. Very useful. It's been pretty easy to use so far. The one gripe I have with it is that the generated class that you get to override it uses standard any, which I'm not a fan of, because I have to do a bunch of, I like returning overrided classes, and overrided classes don't mesh well with standard any. That's why I have all these preprocessors for returning, because even if expression is a class derived from expression context, on the other side of standard any, we would have to cast it to this specific type and not a based type. Because standard any doesn't currently support casting to a base type of whatever type that you put into standard any. It has to be the exact same type on both sides, which is a pain. Yeah. Okay. We're gonna try knocking this out. This is a moldiv. In recursion. Ooh, nice. I've taken a stab at parsers and lexers before. It's fun. It wasn't the best or the fastest, but it worked. Okay, yeah, it was the second argument of this that was causing the problem. So the problem is we are forgetting to set the return type of the function. So visit function call. Oh, there we go. Copilot immediately caught on to that. And then we also want to do this in resolve cast as well. I mean, technically, yeah, it is too. Actually, we don't want args. We don't want to pass in to, we want to pass in from. Because it's from to, and the return type should be to. I'm not actually testing any of the casting code, like it compiles. I'm testing to make sure it compiles, but I haven't tested the actual cast results, and this would have been very fun. So yeah, it has undefined, yeah, if a function isn't defined, we get an error, and if we redeclare a function with the same arguments, it also gives us an error. Though it does allow us to override functions, so we have the same function with multiple different sets of arguments. So that works. But yeah, it is very close to C++ and how it handles all of that. Oh, I forgot resolve operator. But hey, that's working again. So now let's try all the tests once more. Set ref is not an expression. Okay. So the problem here is we're not finding. Oh. So yeah, plenty of bugs with stuff not finding stuff. I do want to take care of the segmentation fault first, though. Oh, we're accessing this after we move it. Before we were using raw pointers. Now we're using smart pointers. I should probably handle this here as well. Actually, I'm not using smart pointers here, so should be fine. Yep, lots of debugging. Right now, I don't have a plan to add in LLVM code directly. I mean, technically, the way that I currently have it working is like the analyzer we can call compile, and we get an intermediate script object, which just has a list of all the exported functions. Exported functions, globals, a definition for struct data types, and then we also have the serialized version of LLVM intermediate representation right here. So if you created something that that wrote bytecode and had like the correct function calling conventions or whatever, you could plug it in here. Might be a little bit of work though. I'm using Copilot, but I don't know if I'm going to stoop to ChatGPT just yet. It's been pretty bad about understanding what my code is doing in the past. I don't feel like posting 8,000 lines of code into ChatGPT at the moment. It might go over its token limit, just a little bit, too. I mean, I could do that, but again, the token limit. All right. Oh, wait. Interesting. Okay, we get another segmentation fault in strings. problem is currently this isn't grabbing functions from libraries. Well, that is one problem. I think I fixed the other ones. Interesting, so none of these got to here. Then again, I don't call very many. Actually, overrides would... Oh, I'm not actually calling overrides of functions from each other. Okay, I need to make this test a lot better. Wow. I think I know that recursion is working because we only have one. API, however, was not. So we're going for libset. Oh, interesting. That would do it. So the problem. Okay, yeah, scoped ID get text. We only want to... I don't have default arguments yet. I might... Actually, yeah, I probably am going to add that at some point. Right now, we're just trying to get it to a point where I can actually throw it into my game engine, so... Okay. While ID no. Child ID node equals ID node child. So then, so the scoped ID, that's just like the segments of identifiers separated by colons. So this that will give us the correct name to search for, the base node. Oh, that's built in. That's pretty cool. I mean, you can get away with an if statement there, or do something funky with templates. Because, I mean, I do something similar in, well, actually I don't, but you can with templates. And if context scope ID is not equal to ID node, then we want to say that our scope is, let's do this a different way. Say scope is null pointer, and then here we're gonna set scope equal to ID node. That way we actually get the parent to this node, and we can pass that in here. So we're gonna say if if scope, yes. So we're actually going to pull something really sketchy here. Because of the way the getIdentifier context works, you actually pass in the base node, which in this case is context scoped ID, and then it stops when child is null. So we're actually going to set oh joy. We're gonna set scope child equal to null pointer, and then after we do after we get identifier context, we're gonna set scope child back to ID node. So this should be a lot better about finding the scope that an object's in and actually searching for the correct function. Cool, API actually passed this time. What's wrong with objects? No operator found for void to float. throw a breakpoint on there. So we are returning. So let's see what we were trying to return. So it's a function call. And I probably forgot to set the return type of the function. No, we didn't find the function. But we just never printed the error. Not find override a function sum with arguments, then we don't have arguments. So I do have conditional loops. So am I actually testing any of them? Let's see, flow tests. So I'm not actually testing it anywhere, but I do have while loops in here. Okay, another segmentation fault. And the problem here is return types. So it's still return types. Do not find override a function sum with arguments. Test struct to sum. Oh, wait a second. I know what's going on. Yeah, I'm planning to add those later. It's really not too hard. It's just I Yeah, trying to get an MVP right now. But yeah, our problem right now is the function call doesn't have any way to determine if it is a member function call, in which case it needs to return a this pointer. Which means we'll need a way to tell it that it is a member function. Wait a second. Oh, never mind. I don't need the repo. I'd be happy to look at it, but I'm perfectly happy with my own scripting language at the moment. Well, not happy because it's not done yet, but yeah. Visit member variable. Oh, wait. This is structures. Visit member access. So yeah, now when we find this function while accessing, well, if we access it as a member, we'll pass the this ref. Right. No, I'd be happy to take a look at it sometime. Don't know if I would get too much use out of it, but I would definitely be happy to take a look at it. I can't remember. Do I put the return argument? Yeah, I do. Return argument always goes last. Identifier this. Oh, this is implicit, right? We aren't gonna have to worry about this. For what I'm worrying about. Okay. If bride's context this ref we want to insert that into the beginning of the list. And we get that in there before archetypes. And I'm going to add an extra check in here just because if and not is member. Just because we don't need to automatically try to add to this pointer if we've already added to this pointer. Objects are now passing. Member functions are working. Time to test everything else. Which, this is the last major bug I can see being a problem, but we'll see. Okay. Void. Yep. Templates. Last bastion of function not found. Excuse me. Okay, this one is easy to fix. Argument string. That's interesting. So, for some reason, both operators aren't being used. In-out functions. You mean like API where the host process can call functions? You can call any of the functions from the scripting language natively. So actually, let's do API tests. Where are you? So yeah, you're able to search for any function and then cast it to the matching function pointer type and then just call it as a native C++ function. And you can do that on any function that's exported. So functions defined outside of exports are only able to be called by the functions within the script. But anything you export, you can just grab from C++, just using the name of the function, and then call it. For input into the function, this setRef is actually defined as external, and right here, we pass in a function pointer to this function right here, and then it's this function right here being called by the scripting language. So the answer to what in-out functions are available is whatever you give it, and as many as you give it. If you did a C++ wrapper for your assembly function, you would be able to add it to my language. In fact, you wouldn't even need to do a C++ wrapper. If you had it loaded as like a DLL or something, and you just pass the... Basically, if you have it loaded as executable code, and you pass a function pointer, yes, you can. So you would be able to create, through the C++ API, theoretically a wrapper for any other language you wanted. Like, yeah. It's just add function. You create the signature that matches whatever function type. You create a header. It's like a little script with just the functions marked as external. So it's the same thing as a C++ header file where you're just saying this exists. You create a signature that matches over here and you pass in the pointers. But yeah, that's another thing that I really wanted to get solid with this was just the communication between the host program and my language. Yep. That you could. If you wanted to use it, that is. Only problem is you'd have to do that through the host process. So anybody wanting to use it that way would have to, in their program, manually link to whatever C++ linking layer. But yeah. Basically, eventually when this is thrown into the game engine, it would be a lot harder to create plugins that are other languages. Though I do have plans for like APIs for that sort of stuff, but yeah. If you're just using the scripting language as its own thing, easy. What was I doing? Right, fixing this. Is it index axis? Right here. No, don't want to do the entire thing. We only want to do strings. There's an L value and an R value. We get all the overrides. There should be one override. There are no overrides. So this is the culprit. Operator plus. There should be more than just operator plus in, wait, which library is this? this is the correct library. Oh, and we do search the structs. Okay, that's good. Struct. Copy. Move. So let's just add this to watches. There we go. There we go. Operator. Curly brackets. Wait a second. Operator. We append the operator prefix. So this should just be that. I should have seen that immediately. Still didn't find it. With argument string. Okay, so it's still the suspicious error. Oh. And because it's unique pointers, we can't rerun that. Okay. Well, I mean, we could have, but I wasn't smart enough in that moment. So get function overrides should return, yep, we get 2 overrides. One of them with constant, one of them's that's for constant strings, and the other that's for non-constant strings. It's kind of similar to how I do it, but not as much, because I don't throw everything into a single list of defined things. I search through the tree every time. Because pain. Oh, okay, this is the problem. Because our value is null because we moved it. I'm not used to working with smart pointers all the time. I usually use raw pointers. Okay, upper call size equals 2. Alright, do I have any other references to value in here that's going to cause problems? Alright, I don't. So many use after move statements. Okay. It's actually working now. There we go. Strings is running. Need to figure out a way to exclude tests. Because while speed is a very important test, I do not need to run it every time because it is pretty much guaranteed to compile with how simple it is. And I need to rewrite it because at the moment it isn't a good test of optimized C++ versus optimized compiler language, because when... Joey, this still isn't working. I don't know why I'm not getting an error before this, though. Because this should be throwing an error before getting to this point. Oh, wait a second. It might be casting causing this problem. Because before, right... Alright, well, see you around. Thanks for sticking around. Okay, so it's int and... int. int 32, int 32. Oh. Float 32. Void and int 30. Okay, so left. You are the problem. Wait. No, it's right, because I have the watches ordered weird. There we go. Now left and right are ordered correctly. Let's try walking through right. See what's going on here. Of course it's a function call. It's always a function call. ID context. Is there any template? No, no template. Okay. Which function are we in at the moment? Visit function. Signature, some recursive integer. Got it. Integer. And then blank. Okay. Interesting. Oh, so we actually found a node. So get identifier context does take care of templates? That's wonderful. If it does. I just need to remember what the grammar for this looks like. So scooped ID. Right, because I was thinking like we only do templates for parents, but no, it's child is the optional one. Right. Okay, so I just don't need to worry about this at all. So a value context and we're gonna copy this whole thing into here. If this is a template, then we just want to say function overrides is equal to new function override context with a singular override that is the node. Oh, sorry. Func context. Just like that. Okay, left and right are good. Left and right are good. Left and right are not good. Okay, right. And source is definitely... Oh, it's not a function called overrides? Ah. Right, because the base one doesn't have a template. Right. Scoped ID doesn't even need template context. Oh, there it is. There we go. That is working now. What is the last one we have not run? Global variables runs. Actually, let's do a full test run, including speed tests, which will take forever. Speed tests is the slowest test, of course. Ref assignment context. Unsafe context. Okay, interesting. Return type is a struct and is ref good. What is our value? It's not a reference. It is void. Okay, what is our value? It's a function call, of course. And source. Oh, right now we're dealing with external templates. Ooh. Return type is void, so the problem is in here. Node is null. So identifier context was not able to figure out that saying last node is library context. No. No, 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 no. This will not work. Oh, there we go. It got all of them. Alright, so it should hit this one right here. And it does. Does it find it? It does. And all tests are now passing. All tests are passing. So I'm going to do a quick commit right now. Which is just that we refactored how we look up function symbols. Don't worry, we'll get to that to-do. Now, we actually add in function pointers. now to decide how I actually want to do function pointers. We don't support lambdas yet. Interesting that it actually picked up on the we're adding 2 and then we're adding 1. That's very interesting that it actually was able to deduce that from all of this. Thumbs up, Copilot. Yeah, we now have an entire fully written test for this. Now in the static analyzer, when we visit ID, well, we already take care of it. We just have function overrides. So what we want is what did I name it? Ref assignment. As helpful as that debug message is, we can in fact reference a function. And we are going to create a function reference context. And then return type is going to be equal to and the type is going to be function plus function argsig. Value type function ref. Okay, what did I actually name it? Function ref. GPT messing me up there. Or GitHub Copilot, to be precise. It's not technically GPT. Do we now have a function reference context? Come on, do the loading stuff. That would do it. Oh, so you literally do just bitcast it. Constant expression, get bit cast of function to return type dot type return type. Okay, we'll just go with byte pointer for now. I won't be super picky about it. Especially if we're using LLVM type, so I can just change it there whenever I need to. Yep. So all function pointers are going to be pointers to bytes. And then now that we have a function reference context that is fully created, we also need a function let's just reuse the same context, and depending on if we have a function context pointer or a expression context to a function reference, that will change how we create the AST. Yep, both of those look good. What did I decide to call it? Oh joy. I was working in the wrong file. There we go. Crisis averted. I guess I do have a use for this function. instance. Looks like I do have to manually extract every single different template type, archetype. There we go. Gonna create something that will just make my life a little bit easier here. Now in visit ref assignment. Actually, no, it's not in ref assignment. It's just... It would be in visit function call. So if this is a functions override context, source dot return type is not equal to value type. Func ref. Alright, and I now remember the thing that I was forgetting to do in visit reference assignment. If our, oh. If function overrides is equal to our value, function overrides context. If L value is return, no. Yeah. Is not equal to archetypes is going to be equal to type identifier function ref archetypes at then we just say best match for archetypes. Implicit cast is a no-go for sure. Okay, let's try this. Oh, it's not gonna work. It might compile, but it's not gonna work. Because oh, here we are. Stack-based vectors. Well, not stack. I'm not sure. Stack functions for vector. Okay. So basically you're just pulling an alloc. Throwing stuff onto the stack. we should have everything here I need. Just need to create that. Then how fast is indexing if that's the case? Does it have to basically pull a linked list and go from element to element? Just tallying up sizes as it goes? Because that's something to take into consideration is if your element arguments are variable size, that means you can't just find an index by taking the base pointer and just adding the offset times the size of elements, which is usually one of the benefits of arrays, is just how fast you can get to your indices because it's one math operation. So that's the reason a lot of times you only have one type in vectors. But yeah. Okay, so it's type first. Got it. And let's see if it likes this or not. It probably won't. It's probably going to throw an error. I'm probably going to have to throw another bitcast in. Expected function or function reference. We didn't even get past the static analyzer. Not at the moment. In the future, I do plan to have capturing lambdas, but at the moment, that's what we're working towards right now. Do you mean nested functions as in like recursion? Because we do have recursion. Like we have functions that can call themselves and functions calling other functions. But defining a function in the body of another function, that is what we are currently working on. No, we don't currently have that. The closest we'll get is lambdas. I think the problem might have just been that we were continuing the function after we really didn't need to anymore. Oh wait, we're testing refs. We want to test function refs. I was so excited that it just worked, you know? No casting operator found for void int. To int. Dang it, we have another void operand problem. Wait a second. That's right, the first... Yep. Let's see. Visit function call. We want this to be +1 because we want to skip the void argument. So we have automatic arg casting implemented for this as well. And if we aren't able to cast, we automatically throw an error. So now we should assert that the type is the same. Now let me check to make sure this is correct. No casting operator found for void int to if int. Ah. So it was actually the error checking was working correctly, but I wanted to add more error checking. For void to function reference int. Oh, we're so close. I can taste it. Come on. Oh, it's return. Wait a second. Is this me being dumb? Okay. Which function is this? Call global func. And we aren't able to return void, so call global. Oh, wait. Oh, yeah. Perfect. Is it function call? Right here. Return type is equal to pointer args 0. Because the first pointer argument, template argument, is always going to be the return type. From return type void to interesting. So we're casting to a func graph from a void. meaning that this left value is... I'm dumb. I forgot the rules of my own language. And that error should tell me the error of my own ways. Because we don't want to use equals, we want to use the retargeting operator. Cannot assign to functions, use the retargeting operator if you want to retarget a reference. Yep. Expression is not a reference. expression is not a reference. Ah. What was the other error? Cannot reference a temporary value. Oh, right. If not a reference, or a function ref, or an L value. This is an L value, so. Yep. Cannot set a reference to a value of a different type. Func int. Function int. That would do it. Then in static analyzer, visit type, get type context, and in here, actually, I can just throw that in there. Pointer to a contained pointer. To a integer 8. value of this. It's a pointer type to a int 8. Is that an indexing error? Looks like an indexing error. It is pretty late. Well, I guess it's early now, not late. No, it's the mental illness sleep schedule. You know, it's not too much big brain about it. Okay, riddle me this. A standard vector with 0 elements in a for loop is still running. We're not going to question the vector that is still iterating even though it's reporting 0 in the debugger, because it is returning the type that I would expect it to return. Function. Oh, okay. That's what's going on here. We only want to do this bit of logic if we are doing regular functions. If we're calling from a function pointer, Ah. Okay, actually that is fine. Honestly, this should work for both types. But called function is not the same type as the call. Okay, so I need to bitcast this. Called function must be a pointer. Bitcast global func to I32. 32. Biggest I-32 to 32. global func. So this is the correct one. Oh. I still had that in there. Should be fine now. Maybe, possibly, probably not. Dang it. Okay, that should solve that issue. See, I told you I would code till the sun comes up. Oh. You cannot deserialize module. Oh joy, not this again. Explicit load store does not match pointd type of pointer operand. Nope, not yet. Once this works, I will. We are very close to getting it working, though. Alright, so the problem is that the explicit pointer type is complaining about that. Okay, visit function call. And I'm going to grab this. It's a problem. Alright, if it's only complaining about this load, then there's a point, there's a chance this will work. It's gonna complain about the bitcast again, isn't it? Or not? Set a global function external. Get global function. Call global function and okay. The problem was just the function signature. It actually did fully compile, which I am thankful for. Okay, it still didn't find it. Oh, that might cause issues later. Okay, yeah, let's refactor that now. Here I was being all fancy, but we don't want a function sig here. Instead, we want what is this join? Copilot making stuff up. Let's see, we want template args to string. And into that we can just pass args. Okay, so we still do need archetypes, but now in document context, in here we'll have to go func ref Come on, I want to see the actual. Funcref int. Funcref int value. What? I thought Did it still do the overridden version of the function? It did, didn't it? Still? Funcref int. Funcref int. Alright, that should be the last one. Wait. I do need to say... function arguments. Empty. Alright, let's see the errors. Call global function. It expects a value. It works. I may rest. All right. Good stream. I got it done. The sun is shining. It's a beautiful day out. It's time to go to bed. All right. Well, see you next time. Thank you to those who watched.